Perfect. All right, so good morning, everyone. This morning we're going to talk about OpenNMS integration patterns. So basically what that is how to integrate OpenNMS with existing tooling in your infrastructure and kind of take a look at the different facilities we have for getting data in and out of OpenNMS. So we'll touch on different facets there. Basically, this is just an excuse for me to give a whirlwind an overview of a bunch of different components and kind of get our hands on and look at kind of how those work and how you can actually use those. So first, a bit about me. Name is Jesse White. I'm the CTO of the OpenNMS group. So I started using OpenNMS in around 2012 as a user, looking at bringing monitoring into the company. That was also the first year I attended DevJam. In 2013, I participated in Google's Summer of Code. Ronnie Trum over here was my mentor. And I formally joined the OpenNMS group in 2014, moved down to North Carolina, and then last year moved back to Canada and formed the Ottawa office there. So since then, we're now a team of 3 guys in Canada. There's myself, Matt, and David, who spoke yesterday there as well. So a few things we're going to go over today. We'll just brief look at the kind of architecture and how the different components we'll be talking about fit together. Then we'll touch on events, alarms, inventory, performance data, and finally look at what we've been doing with Kafka lately. So here's the kind of architectural map. Right at the bottom there we got event D, so something you guys may already be familiar with, one of the core components in OpenNMS that allows the different bits to talk about, different components to interact with each other. We also got some components related to time series, the database, and all these things that kind of plug in there. So the goal is after the talk, this should make a little bit more sense than it does there now. All right, so let's just get started briefly with events. So how can we get events into OpenNMS? Right, so of course we support being able to handle syslogs, traps, things like that generated from devices. But what if you have an application that wants to send an event in, or some custom integration? Well, we have TCP and UDP listeners for EventD that allow you to kind of send an XML-based, what we call event log, into those sockets and be processed by EventD. So an event log is essentially a group of events. So one log can contain many events, right? And the idea is you just send that to the TCP socket, the whole event log over the one connection that gets processed and handled asynchronously. So that said, whenever the connection terminates, that event will eventually get processed out of band in an asynchronous fashion. And the kind of schema there that we use is XML, and the XSD and the formatting for that has not changed in a while, so it's very, very stable. Not too sure exactly when that was introduced, but I assume it was there since day one. Antonio's waving his hands a long time ago. So that's basic way, right? Send XML over the socket, and it gets processed by EventD. One of the limitations there is that there is no authentication on that port, right? It's just plain text, open. So if you're looking at something more secure, what you can do is use the REST API. So as of 17.1, I believe we introduced the ability to send events in via REST, right? So little thing that's different here is that we no longer accept an event log, just individual events. So every post is an event. So that allows you to achieve the same functionality, although you can use XML or JSON for that. And it does require a valid role with permission to be able to post to that endpoint, and you can enable security via TLS, et cetera, if you want it encrypted. So let's just hop out to a quick demo of those two things, kind of get our hands dirty here. So what we're looking at now is I have an instance of OpenNMS up and running here. There's only like a single node local host, which is provisioned. It already has some alarms. And here we are. So all the things we're going to look at today are in a GitHub repository, so you can kind of follow along, or if there's any of these particular tidbits of configuration that you want to use, you can just pull out of here. The link will be available in the slides. So let's go with first one. So let's look at sending an event in via the TCP socket. Right, so let's look at this sendEvent.sh script. Is the font big enough, or should I make it a little bit bigger? Maybe turn syntax off. All right, so you guys may already be familiar with the sendEvent.pl script, right, used for administrating OpenNMS. That actually, the way it sends those events is via that TCP socket. So what we can do is just go ahead and trigger the script. It'll send the authentication failure event, and we should see that come up in the web UI. So let's just go ahead and run that here. All right, and I enabled it with verbose mode, so you can actually get an idea of what that XML looks like. Right, so sent localhost port 5817. Here's all the body, and if we go into the web UI, we should see that event. So events. So here's that thing we were talking about yesterday. Want to go see the events? Now I got to click twice. Okay, and there's that authentication failure event that I just sent in. Okay, so let's look at the next one now. So there's post event XML. So again, this one's the same similar event, although I'm sending it to OpenNMS by posting it to the REST endpoint via curl. So there's kind of the body, and the URL is at the bottom there, OpenNMS REST events. So if I go ahead and post that in, I get a 202 accepted code, meaning it's not, whenever it returns, it doesn't guarantee that it's immediately processed, but it's been queued for processing. So at a later point in time, it will be handled. All right, I got 2 now. And finally, there's another example here, post event JSON. Same thing as the previous, although we're using JSON here in XML instead of XML. Question? Yeah, every time. Okay. A little clear? Yeah. So there we are. Same thing, except JSON instead of XML. Again, 202 accepted. All right, and there's another event, right? So those are, just a couple simple ways you can do to get events in OpenNMS and incorporate those in your applications through writing scripts or integrating with OpenNMS in some way. All right, so we got events in. Now, how do we get events out of OpenNMS? So what if you're interested in actually triggering a specific action whenever a particular event is sent? Well, one facility we have for doing that is scriptd. Again, not too sure when that was introduced, but it's been around for a long time. And that basically supports a number of scripting languages and extensions using the Apache BSF project. But essentially, any JSR 223 compatible script is basically a standard for scripting extensions in Java, should be able to execute in that environment. So some examples of scripting languages are Bean Shell, Groovy, Python, etc. Whatever you like, chances are it's there. One thing to note about that engine is that it's single-threaded, right? So your event handlers or things that you're doing there is only one thread running those, so you can't do anything that's too computationally intensive, or if you're depending on other systems doing requests there, and those tend to time out often, the events will kind of backlog and queue up. So just be aware of that if you tend to use that, but it's good for quick and simple things. So let's see how that looks like. Okay, so scriptd. So there's a configuration called scriptd-configuration.xml, of course. That kind of looks like this. Let me turn the syntax off again. Okay. And the idea is that you define what languages you use, and you could have different scripts. So essentially this block here, saying I'm using the Python language. I want this script to be triggered whenever this UEI is sent. So basically those events that I was sending out in the previous example, I want this block of code to be called whenever those events are sent. Right? So in this case, I've actually importing this utility called the event forwarder. So this is an example of where we kind of externalize most of the code outside of the script, right? So outside of this XML file. Putting code in an XML can get pretty unwieldy very quickly. So the idea is you want to be able to move that out and just reference the necessary bits here. So let's look at that. So if I look at my Python module, the actual utility script, so this basically gets called whenever the event is triggered, and we'll do a HTTP post, right, to a web server that's on the local host here. Let's look at my notes for this one. So what I want to do is go ahead and start an HTTP server. Simple HTTP. So I now have a web server listening on port 8080. It's not going to actually handle the post request, but at least we'll see a log message whenever it does get hit here. So what I'm going to do now is copy over the configuration that I have here onto my OpenNMS home. Okay, all right. If I go here, I look at the script configuration. That's what I have there. And I can now go ahead and trigger reload on script D, and that will make the configuration I just put in place in effect. So I got this little wrapper script here, script D. There we go. So script D should now be running with the new with the new configuration. Just so there's no magic there. If you want to look what reload daemon does, it's just a wrapper around the send event command. So that's it. And there we have it. So now we have that script running. If I send an event in, I should see a call go out. If not, I did something wrong. So let's go ahead with the JSON version. It's been accepted. And of course, it did not trigger. So let's look at the script D logs, kind of get an idea what happened. Unsupported language Python. Okay. So what that requires is this Jython library should be there. I'm pretty sure I copied that over. Jython standalone, 36 megs. That's there. Not too sure if I restarted since I last put that. So let's try restarting and then see if that does it now that the jar is in place there. So yeah, OpenNMS can take a minute or two to restart, so maybe we can come back to this one. Oh no, it's coming back up there now. So what I like to do is just tail the manager log while it's coming up, get an idea of where it's at. So the instructions for doing this are actually in the README here. So there's a copy of the jar file that you need to download, put that in the lib directory, copy over the configuration, run the reload command, and then have an HTTP server to actually handle those requests. Okay, so Jetty's starting up, so let's try this again. I want to trigger post via JSON. Of course, Jetty's not up, so it can't handle the post yet. The other one may be up, though. Okay, there we go. So the problem is I hadn't restarted OpenNMS since I had put that Jython jar in the class path, so it wasn't in effect yet. So here I see that a bunch of things were triggered, and eventually I get 501 error back, post is not supported. That's because this simple HTTP server here doesn't handle the post. But the main important part here is that we did get a post. So I sent an event in, post was triggered, web server got hit with it. So if we do it again, we should see another post, right? So there's a quick recipe you guys can use if you want to start handling events via Python, or adapt that for any other language that's supported. Okay, so like I mentioned, script D has a number of limitations, right? and that all the code has to kind of live inside of OpenNMS itself. It's single-threaded. What are other ways that we can use to get events out of OpenNMS? Well, we do have this AMQP forwarder that could be used to push events out from OpenNMS to an AMQP compatible broker. So if you were listening to Craig's talk there yesterday, AMQP is a messaging standard similar to MQTT, right? Supported by a number of brokers. And there's quite a lot of advanced features with that forwarder, but we'll just touch on the basics here. And yeah, so basically you can enable the forwarder. It'll get the events, it'll push them out into AMQP. So what we'll look at is a quick example here of doing that with RabbitMQ and see how that kind of looks. Okay, so we can stop this. Okay, so first we're going to go ahead and start up RabbitMQ. So the way we do that is via Docker, as it makes it easy to start these arbitrary services. One thing to note is we use AMQP version 1.0, and that's not enabled by default in RabbitMQ, although it's supported and bundled there, it's just not turned on. So we're going to go ahead and do is this command here actually make sure that that plugin is in fact enabled. If you're paying attention to Ronnie's talk yesterday in volume mounts, what we're effectively doing is mounting the enable plugins file inside the container. So let's start RabbitMQ. So CO, follow the logs for that one. Okay, so RabbitMQ is up. So here we can now start a consumer. So this is a simple Python consumer. All it does is establish connection, starts listening from a queue called OpenNMS events, and then prints out the messages as it gets them. All right, so let's try that out. Okay, it's waiting for messages. Finally, we need to enable the feature in OpenNMS. So in the README file here, I think I have a quick example. So this one is one of the carafe features that we have. So it's available there by default, but not turned on. So what we have to do is configure it, tell it where we want it to publish the events, and then start up the feature. So to access the carafe shell, what you want to do is you want to SSH port 8101, localhost, use the same credentials that we use to log into the OpenNMS web UI, and here we go. We got the shell up. So let's go ahead and just copy this blob here. This is actually documented in the developer guide. Okay, so there's a bunch of config sets. Finally, we'll install the feature. So I could just do that. So feature, install OpenNMS AMQP event forwarder. Okay, cool. All right, so that should be up now. And there we have it. So technically now we should be forwarding all the events that are sent to that queue, and our little Python consumer here should get a copy of those messages. So let's go ahead and trigger a bunch of events. So there's actually a command in the carafe shell that many of you may not be familiar with, but it's the events : stress, and what that allows you to do is events : stress is just generate a bunch of events with particular properties, right? And just send as many of them as possible. So that can be used for testing a number of things like performance testing, etc. So here we are. We'll just copy this command here. So what we're going to go do is send a bunch of auth failure events. We want to send 10 of them per second for 1 second. So effectively generate 10 of those events. And there we are. So we sent a bunch of those events out. And we see here that the Python consumer listening to the queue now got a bunch of those messages. So getting the XML messages out here. All right. So This allows the code to live outside of OpenNMS, and it can, take its time, and you can deal with whatever applications you want. You don't have to worry about blocking up the single thread, right? So we just showed a little small piece of the AMQP forwarder. There's actually also an AMQP event receiver, an AMQP northbounder, and there's facilities to be able to kind of mangle and modify the events and make a number of changes there. But just a brief overview, we see that it works with the latest RabbitMQ and that we're able to get events out. Okay, so I could just keep that up and running. And we'll close this up. Okay, so go back to my presentation here. All right, so we got events in, we got events out. So let's move on to alarms now. So how do we get events into OpenNMS? Sorry, alarms into OpenNMS? Well, alarms are triggered by events. So we've kind of already covered that. You send events, particular events based on the configuration will trigger alarms. So we kind of already know how to do that. Let's, however, look at how we get alarms out of OpenNMS. So we have a bunch of facilities called the northbound interfaces, right? So those allow us to run a variety of things whenever alarms are triggered by alarmd. So some of the built-in ones that we have are sending syslog messages, SNMP traps, publishing the alarms to JMS, to AMQP. Again, there's even more than that. You can run BSF scripts, similar to what we did with the scriptd examples. Just quite a lot there. But one big limitation that you have in a northbounders is that they're not aware of all the changes done to the alarms, right? So only changes done by alarmd itself. For example, if a user were to go and acknowledge an alarm or clear an alarm from the web UI, that would not be reflected in the northbounders. So just keep that in mind whenever you're using these integrations here. All right, so again, let's kind of look at how that works. In this case, what we want to look at is being able to send a syslog message whenever an event is, whenever an alarm is triggered, right? So the way we do that is we enable the syslog northbounder. So that's something that I've already done. So there's a configuration here, syslog northbounder configuration. Basically, you just set this flag here at the top from enabled false to enables true, and then there's a number of other options there with respect to formatting and where you want them to go. I just kept everything as a default here. Okay. And then the default destination is localhost port 514. So if I just run a TCP dump session here, I should see the syslog UDP packets being sent out. Okay, and then how do we generate or trigger a bunch of alarms? Well, again, we can go back to that event stress command. And in this case, what we'll be doing is sending 100 events per second over 10 threads and calling this generating this particular UEI, which has alarm data. And this last part of the command here is a Jexel expression that allows us just to introduce a little bit of randomness into those and change the parameters such that we generate more than just one alarm. So let's go ahead and do that. Okay, so this is going to start just flooding OpenNMS with events that trigger alarms. And I see here that my TCP dump session just keeps, spilling out messages. Every time those events are handled by alarmd, it will go ahead and send out another syslog message. So that could be useful if you want to integrate OpenNMS with another NMS system in your environment or some other tooling that takes input as syslog messages. You can work out the format there and have those forwarded off. We can also look at those in the web UI, kind of see what alarms we did in fact generate. So there's all the events I sent. Status alarms. Okay, yeah, I see that. There's that one alarm here with a very large count. Okay, so that's it for, that's just one of the north bounders that we have. Kind of give you an idea of how that works. Okay, next. So that was it about alarms. So we now know how to get events in, events out, how to trigger alarms from external applications, how to get alarms out of OpenNMS via syslog. Now let's take a quick look at inventory. So can we get inventory in and out of OpenNMS? Well, one way to do it is via the REST API interacting with the provisioning requisitions. So that is something that's been around since, I think, 1.8 when we introduced provision D, or maybe even before that, not sure. But it's been around for a while and performs reasonably well. And so we can look at that quickly. There's actually a script in OpenNMS provision.pl that interacts with the REST API already. So we'll take a quick look at how that works. Okay. Close this one. All right, inventory in. So I just got a bunch of notes here on how it works. What I've done is actually modified or patched provision.pl a little, so it'll actually show the requests it's making, right? That way you guys can actually see what it is in fact doing. Let's try that. We want to just add a requisition called test. So what it ends up doing, it's an HTTP post to REST requisitions, and there's the content of the actual body. All right. Then next, we want to go ahead and add a node to that requisition. So we're creating a new node in the test requisition. The foreign ID is test node foreign ID, and the label is test node label. Next, we want to add an interface to that node. Again, similar. We can add a category. And finally, we can trigger an import for that requisition. I forget the command for that offhand. Requisition import test. So requisition import test. Now if we go to the web UI, so all that communication from that program is done via the REST API. So we should now have two nodes here, test node label that we just added. So that is one way to get inventory in. Of course, you can still use discovery, manual provision, or an integration with PRIS that helps you generate the requisitions automatically. But just give you an idea, if you want to write scripts or integrate it with some existing application, again, you could just use the REST API, generate those similar calls, and build up the requisitions. Okay, so now we got inventory in. How do we get inventory out of OpenNMS? So again, we can look at using the REST API. So being able to get nodes out of OpenNMS has been there ever since we've had the REST API. But one cool thing that we've added recently is the V2 REST API. So what that allows you to do is make more flexible queries and kind of try to isolate the resources that you want to pull out. So let's take a quick look at what that entails. All right, inventory out. So let's look at this query here. Okay, so what it is we're making a get call to API v2 nodes. And here is the query expression. So right now we're saying match any nodes that have a label that starts with test, which should return the node that we just added. So now what I'm doing is I'm piping that output, which is just a bunch of JSON, to this JQ command, which will allow me just to show the node label and ID. So if I go ahead and run that query, again, I see the node label and ID here. If I remove that JQ command from that query, we'll be able to see the full output of everything, right? So it's kind of a neat way of pulling out specific bits that you want. So there we ended up pulling out node label, right? Running a query against that. But there are actually a lot of different properties you can use to filter and query. The language that we use here for those queries is called fickle and allows you to do compound and or expressions, and you can get pretty complex in what you query for. So the next one here is one thing we've added to the V2 REST API is the ability to enumerate what properties are available. So that's the big problem. So we can query on all these properties, but what's there? So we made an effort to help make the REST API as like self-describing as possible. So again, what we do here is just calling a get on the properties. So give me all the properties, and then we pipe that out to JQ to be able to print it here. So if we look at that, you know, they're just done. So you can filter based on, you know, asset records that contain this value, start with this, so on, so that end is in this category, et cetera, et cetera. So all the node properties are there, along with some of the auxiliary tables that it links to. So that's it. All right. So just brief tour of inventory there. So now we know we can get inventory in and out via using the REST API. Okay, so let's look at performance data. What can we do in terms of performance data for pushing that into OpenNMS and getting it out as well? So one thing we've added in 21 is, as part of the Drift project, is the support for streaming telemetry. So what we're able to do now is actually push in metrics instead of relying on OpenNMS to go ahead and pull those from the devices. So we've added kind of a framework that's extensible for supporting new protocols and being able to handle those. As of recently, actually just yesterday, we merged in a pull request to our develop branch for 23 is to be able to process those at scale. So you can now scale out your handling and your ingress of those messages using Minion, and you can also scale out the processing of those and the persistence using Sentinel on the back end, and persisting that to newts. So we now have a horizontally scalable solution for dealing with streaming telemetry data, which is pretty neat. Okay, so let's look at kind of how that works. So for streaming telemetry, we have this new service called Telemetry D. So it's enabled by default in OpenNMS, but I don't think any of the listeners are enabled. So let's turn syntax off here. So we see there's a number of protocol definitions here. We've got JTI, NetFlow, IPFix, SFlow, and XOS. So what we're going to do is look at enabling the JTI protocol here. So again, we set enabled false to true. Two parts of the blocks here. One is defining the listener, saying I want to open up a listener on UDP port 5000. And I want those packets handled by this adapter here. So effectively, that will decode the JTI packets and then pass them to the script that will work to extract the metrics out and then push those to the persistence layer. So I just enable that. Now to make that in effect, I can go ahead and reload telemetry D. But first, let's just make sure that so nothing's listening on port 50,000. Reload daemon. Okay, telemetry D is up. I now have a listener on port 50,000. Let's see. Okay. So what we're going to do is run a script that just generates a bunch of JTI payloads with random interface data, just to show that it works. Those will be associated with some new nodes. So what we're going to do is just send out a bunch of new suspect events here that will provision the nodes such that the metrics that we're sending can be associated with something. So let's go ahead and send those out. It normally doesn't take very long to get processed. I should have a couple nodes show up there. So now we've seen two ways for getting inventory in via requisitions and sending new suspect events. All right, so I got the nodes there. Let's go ahead and generate a bunch of JTI traffic. So what I have there is just a wrapper script around this jar file, and there's a link to it in the README here. So sent a bunch of JTI messages. If I follow the logs, I don't think it's, yeah. So you see there's already persist operations here. So we did in fact update something. Let's go ahead and look at it here if I refresh. And there we go, bunch of interfaces. So we created a new node, and we just pushed a bunch of metrics related to that node using the JTI protocol. Right? I think there's 50 interfaces there. Yeah, cool. So that's just really brief look at telemetry D and what it can do. So we've shown that we can get performance data into OpenNMS via push. Yep, go ahead. So the sure. Yeah. So the question there is, are you able to send JSON structures for the performance data? And the answer there is yeah. We don't have support for that built in because there's no real, standard way of formatting the JSON metrics as far as I know. But it could be added reasonably easily. Okay.
Especially the EFA, but I think someone has it, and if you are able to send a JSON struct into OpenNMS, this would be very beautiful.
So you'd write your own script that would pull out the metrics and then build a JSON and push that out. Okay, to do it. Yeah, that'd be a way of doing it. Another question?
You mentioned it supports Cisco Nexus operating system.
Yeah.
What kind of information does my Cisco router send to OpenNMS, and what can I see afterwards?
So I know at least interface levels. So the question was, if you use the NXOS support, what kind of metrics can you see once that's enabled? And the answer to that, I know you can at least do interface level metrics, right? Like if in octets, if out octets, errors, things of that nature, some CPU related stats about the chassis. But aside from that, I don't know the details, but we can look over the schema together if you like.
So this would be an alternative for asking via SNMP?
Exactly, yeah. So it's an alternative for SNMP. Instead of querying it, the devices will push it, and so you've now moved the control of what to collect and how often to collect from OpenNMS onto the devices, right?
Second question, net flow data, S-flow data.
Yeah.
I have no idea what OpenNMS presents me in a graphical way from S-flow data. Do you have an example for that?
The question is, what will OpenNMS present graphically in terms of net flow and S-flow data? And the answer there is so there's two different parts to that, right? For net flow and S-flow data, there's the actual flows themselves, right? So basically, flow is like a summary of this host talked to that host during this period of time. They transferred these many bytes, right? And there's some of those protocols also support like performance data. So for example, S-flow, in addition to sending information about the packets, will also send information about the devices themselves, CPU usage, etc. So if we're talking about the flow side of things, we have a tooling called the deep dive tool that David touched on briefly yesterday that allow you to look at the traffic and kind of basically your traffic, if in octets, if out octets for a particular interface on a router. It's just high level summary. Here's what was transferred. Well, with that data, what we can do now is break that down and show here's the distribution of traffic amongst these protocols. So that's that. And for performance data, it's similar to the JTI. The way it works is that we extract the data out of these packets, and then it would be presented just like any other performance data would in OpenNMS. So if we receive CPU usage from SFlow, we can then persist that and graph it as well using the standard facilities.
Are there somewhere any screenshots about that feature?
What screenshots about the flow one? I can give a quick demo of it maybe after this, and kind of give you an idea of what that looks like. How it works? Yeah, no problem. So we had a quick question there as to whether or not telemetry D only works with newts, or does it work with RD and JRobin as well? The answer to that is yes, it does. It works with all the persistence engines that we have. The only limitation is that currently it does RD and JRobin persistence don't work when you're using Sentinel. So that requires you to use newts, mostly because the processing of that is distributed and we can't handle concurrent writes to the same files and causes a bunch of problems, so we only support newts for that. David, question?
There's probably a management pitch, right? Because when you're using RD, kind of specifying what the interval is for collection in the RD, and you can take it at any interval.
Yeah, that's a good point. So when handling streaming telemetry, or limitation of RD tool is you need to kind of know how often you expect to receive the data, right? And with RD, you need to know that beforehand whenever the RD files are created. So in the telemetry deconfiguration, there's actually a blob there that lets you define the RA definitions. So you can say, from these hosts, I expect to receive these packets or these payloads every minute, so you can adjust your RAs accordingly. If you were using newts, however, you wouldn't have to deal with that.
You'd have to delete your RDs if you already defined them previously.
Yep. So if that frequency were to change, you would then have to remove the RDs or alter them in some way to support the new rates. Yep. Yeah, so there are definitely some advantage to using newts and doing late aggregation, particularly when doing streaming telemetry instead of the traditional poll-based collection. Okay, so we've got, we are able to push metrics now. See, there's a lot of interest there in that telemetry D bit. I think it's fairly new too, so there's not much knowledge around it yet. But let's look at how we can get metrics out of OpenNMS now. So we have a feature that's called the TCP exporter. So that's something that was added way back in 1.7.9. I actually traced the commits back. And what we do is we send RD updates via protobuf format out on a TCP socket, right? So you can set up, okay, hey, here's where I want you to send all the performance data. And I got a screenshot of the protocol there. That's been, I think, hasn't changed since we've introduced the feature, and give you an idea of what it is we send out. So the values there, we send the path, and then the timestamp, a double value, and maybe a string value. All right. So let's kind of look at what that looks like. Okay. So to enable the TCP forwarder, you got to basically set a number of system properties that are in this little block here. So we set use TCP true and basically where to send it. So this command, basically what it'll do is just take those properties, put it in openms.properties.d, and which will make them available at the runtime. So this is a good way to manage system properties without having to edit the existing files. Any customizations you do, you normally just want to do them via the .d folder. So let's look at that. I think I've already enabled that because it does require a restart. RD TCP properties. Yeah, there we go. I think we're at 8 performance out. Okay, and what I have here is, again, a small Python script that implements that TCP listener. So listens on port 2424. And we use the twisted framework to do this, but the idea is whenever we get a TCP connection, we just buffer all of the data that we receive. Whenever the connection closes, we take all the data that we've buffered, pass that to the protobuf, decode those objects, and then print them out. So let's go ahead and set that up. So now we're listening on port 2424. And then we can go back to the previous example and just generate a bunch of generate the streaming telemetry here, and there we are. So I'm pushing data in, and I'm getting the data immediately back out via the TCP socket. So let's just look at what that kind of looks like. So the messages we get here are the path, the timestamp, and the actual values, right? So the path would be the path on disk to the IRD file or JRB file that you'd persist, timestamp, and then the actual value of the metric, right? So one limitation with this is that it does not work with newts, only works with IRD tool or JRobin persistence, right? So we have a few clients that are using that to get performance data out of OpenNMS and stream it into their own platform. Okay. All right, so we've kind of looked at events, alarms, inventory and performance data, touched on how to get all those in and out. As you saw for each one of those, it's got kind of different ways of doing it and different quirks, right? Different performance characteristics, different schemas. Some use XML, some use protobuf, etc. So what we've been doing is actually working on getting OpenNMS to push more and more data out to Kafka. So Kafka is a scalable broker that allows you to do stream processing and a bunch of really cool things. So what we're working on is making it possible to stream all the data from OpenNMS to Kafka and having kind of a consistent model that you can leverage. Also making sure that that model is stable and can easily be used across versions of OpenNMS. So for that, we've been using Google Protobuf, so that makes sure that the objects we're building are, of course, backwards compatible and allows us to make extensions and add data to those over time. Another interesting thing is that we can support many consumers of that data using Kafka. So once data is in a topic, you can have many applications reading that data and processing it in parallel. And you can also have access to historical data. So based on the retention periods you set, you can even play back old data that was there in those topics, right? So you can, for example, push all your events, all your alarms, and then go and play those back for some arbitrary period of time and see what that looked like. And it also, it's very scalable platform. So all the brokers are kind of distributed in, and you can break it up into as many partitions as necessary and get basically the performance characteristics that you need for your environment. So let's kind of briefly look at how that one works. So this is a new feature that we've added, I believe, in 21. So the ability to be able to push out the events, the alarms, and the inventory. And as of 23, we've also added the performance data in there. So for Kafka, what we can do is, just go ahead and start Kafka. And again, for this one, use Docker. Start a quick Docker image, bound the ports locally. Okay, so the Kafka image is started. Okay, it's in a running state. Now we can enumerate the topics and see what topics are created in Kafka. There aren't any. So if we look at what that script does, it actually executes a command within the container and then shows the output here. So as we do more things, we'll see that that there will be some output there. And yeah, so now we've got our Kafka instance up. We want to go ahead and enable the feature in OpenNMS. So again, this is a Carafe-based feature. So we can configure it and enable it from Carafe there. So let's just paste this whole block in the Carafe shell. So just briefly, what that blob does is, first part of it, we are configuring the Kafka client. So we're saying, here's where the Kafka server is. It's at the localhost port 9092. Second blob is the actual producer option. So this controls like the name of the topics we send to, which features are enabled, and some of the characteristics there. And finally, we install the feature. Okay, so the feature is up. Okay, cool. And let's try that list topics command again. Nothing has been sent out yet. So let's just go ahead and trigger some alarms. And if I go back to that, actually it should be in my shell history here. Event stress. All right, so I see I have some alarms and some events here. So now let's go ahead and generate some performance data. I should see a new topic for that show up as well. So I got metrics there. And finally, we want to be able to show the nodes here too. So the way the nodes are pushed out to Kafka is they'll only be pushed whenever an event happens with that against that node or an alarm. That's what triggers the push out. So if I go ahead and synchronize one of the requisitions I created, that'll generate some events related to those nodes, and then the nodes will be pushed out. So synchronize that first requisition. All right, so I now have, I see there's a few topics, alarms, events, metrics, and nodes. Okay, so again, to the world of Python here, we have a consumer. And what that'll do is basically Kafka client, Kafka consumer for those topics. So we see here this line, we're subscribing to alarms, events, metrics, and nodes. Taking those messages in and just decoding them from the protobuf objects and printing them out as we get them. So the consumer that we're using there, or the protobuf file, uses protobuf 3. And whereas the previous example used protobuf 2. So what I just did there was switch to a Python virtual environment that has the protobuf 3 libraries loaded here. So, and let's start up the consumer. Or maybe it doesn't. I think deactivate. Okay, so something's up there. Let me just blow away the virtual environment and try restarting. I think I had, yeah, we'll do this here. Oops. Okay. So Python consumer. There we go. All right. So we just recreated the virtual environment from scratch, ran the consumer, and it's now printing everything that's available in those topics. So we see we got information about nodes here. We got information about events. And we got information about performance data. So one thing to note here is that the model we're using to send out the performance data doesn't look like the model from the TCP exporter. So the TCP exporter we looked at actually included the path up to the RRD file, or that the metrics were persisting. Whereas here we include it closer to how it's collected. We include the notion of resources, groups, etc. So that makes it a lot easier to decode and use the data. Prior to that, what you had to do is actually decode that path string to determine what the metric is related to, right? So from that string, what node is this metric related to? Well, it depends, how far down the path do I have to go? What resource is this related to? Well, again, it depends. So we've taken all that work of having to decode that string out, and we now present it in this new format here instead. Okay, and just one other thing to touch on here, that we push out the alarms as well, and we have a couple shell commands here that kind of make it easy to show what's in Kafka. So Kafka producer list alarms will show the alarms that are currently present and active in the topic. And we also have a synchronize command that basically periodically it runs automatically. You can also trigger it manually here. And what that does is make sure that the contents of the alarms in the topic match what's in the database. And that gets performed every so often. So that makes sure that there's an accurate representation of the alarms in the Kafka topics as there is defined in your system. So what this allows you to do is now pull all this data out from Kafka and then write your own applications on top of that, and gives you a nice consistent interface for doing that and getting access to all these various things, right? So far we've gone ahead and leveraged that to do an integration with CA Soy. So that's one of the CA products they use as kind of an integration platform. So we use that to synchronize OpenNMS alarms and get those pushed out. So the Soy integration basically uses Kafka as a source for all of its data. We're also leveraging this for the correlation engine, such that all the alarms as they happen, and along with the inventory and the related assets, get pushed out, and then the correlation engine is able to process those and actually live outside of OpenNMS and get access to that data in real time as it happens. So that's some of the applications that we're kind of working on, but we're making sure that all the facilities are there so that other people can do cool things with it as well. And that's it. So kind of whirlwind overview of all these features. Again, Jesse, so my handles are up there, and that's it. Well, thanks, guys.